Okay, the law of sines, day 2. Now we're going to be looking at the side-side angle scenario of the law of sines. We saw the two angles on one side scenario yesterday. Two sines and one angle means that we would have knowledge about two consecutive sides. For example, this side over here is, let's say, 12. This side over here is, let's say, 31. And then the angle that we have knowledge about is not the angle in between them, but one of the outside angles right there. So let's say this one is 20.5 degrees. So that's this angle right here. So this is our SSA scenario. And this is what is known as the ambiguous case. And the reason it's known as the ambiguous case is because there is a possibility of multiple triangles being a part of the solution. In other words, not just one single possibility for this side or for these angles. What we actually get are three possibilities. Possibility number one is that there is no triangle. No triangle exists. That's the best one, because that means there's not very much work to do, and there is simply no solution. The second possibility is that two triangles exist. That means that there are two solutions for each of the missing sides. And then the third possibility is that there is only one triangle, or in other words, exactly one triangle. And that means that we will simply have one solution. And then it would work pretty much exactly like the other ones that we just saw when we did the two angles in a side scenario. So we're going to look at all three of those scenarios. We'll do one example for each. So for the first example, we are going to be given the information. Actually, we're going to work with that triangle that we had in the previous example. So let's call little a 12. Little b is going to be 31 meters. And angle A is going to be 20.5 degrees. So if we represent that visually, maybe a little sloppy, sorry. In this scenario, the only thing that we can actually find right now is the angle across from the 31. That angle right there is the only one that we can find. That would be angle B. And that would leave us with C and little c as the other things that we would need to find. But based on the information we have, the only ratio that we can actually set up is going to be the one involving angle B. And we have, of course, angle A and side A to work with. So that's definitely what we're going to start with. So if we did 12 over the sine of 20.5 is equal to 31 over the sine of angle B. That's going to allow us to find angle B. So if we do our cross multiplication, 12 sine B is equal to 31 sine 20.5. And then if we divide both sides by 12, then what you'll get is the sine of angle B is equal to that 31 sine 20.5 over 12. But that's going to tell me what the sine of angle B is. That's not going to tell me what actual angle B is. So in order to find actual angle B, we're going to need to do the inverse of sine, which if you remember, that means that what we are doing is arc sine, or sine -1. And then we're going to arc sine this 31 sine 20.5 degrees over 12, and that's what we're actually going to have our calculator do for us. So when we do our arc sine, we're going to find out that angle B is approximately 64.783 degrees. But there's actually a second possibility for angle B, and the way we're going to find that is by doing the supplement of the first angle that we just discovered. And that's going to give us the second possibility for angle B, or in other words, 115.217 degrees. So when we have an ambiguous case where we have two sides and an angle across, then we're going to find the second angle by doing exactly what we did right here, by taking the first answer that we just found, the first angle that we just found, and subtracting it from 180 to get the second angle. You'll see in the next two examples, after we finish with this one, how it becomes obvious that there is either no solution or only one triangle. That will be clear in the next examples. So, what we have here are, we have two possibilities for angle B. We've got our B1 right there, and we've got our B2 right here. And so, what that means is we are going to also have two possibilities for the other pieces as well. So let's talk about B2. Let's do that in a different highlight. So when we're talking about angle C and side C, the next thing we're going to want to find is angle C. And angle C is the third angle. We have two angles already. Remember, we had the original angle A that they gave us, and we have the angle B's that we have right here. So angle A, given, that's just going to be 20.5. And then to find C1, we're going to use angle B1. So it's going to be 180 minus the two angles that we already know. And then when we actually perform that subtraction, we are going to come up with a value that is 94.717 degrees. So there is our angle C1 to go along with our angle B1. And then to find side C1, we are going to apply the law of sines one last time. So we want to do, we can use either A or B. I'm going to use A. So I'm going to do my 12 over sine 20.5 equals, and then I'm going to find lowercase c, that's the side we're looking for, over the sine of the angle that we just found, 94.717. And again, just like we've been doing, we're going to cross multiply and solve. C sine 20.5 equals 12 sine 94.717. And we're going to divide by the sine of 20.5. And that's going to give us our calculation right there. So our C value, C1, little c1, is going to come out to 34.149. And you remember we were in meters for this problem. Okay, so there is our work for C1. And then for C2, we are going to do the same thing we did before, except this time we're going to be dealing with C2, and what we're going to get is we're going to get another 180 minus, and then this time the two angles that we're working with for this triangle were the 20.5 that we had all along from angle 1, angle A, plus now we're going to be using B2, and so that's the 115.217 degrees to get us our C2 value. And when we do that calculation, that's going to come out to 44.283 degrees, and that's going to be our C2 value, our second value for C. So if we're going to find our side C, then that means that we're going to set up another ratio just like this one, except that instead of using the 94-degree angle, we're going to be using the 44-degree angle. And so that's going to give us 12 over the sine of 20.5 equals little c2 over the sine of 44.283 degrees. And again, when we do this calculation, we can cross multiply and simplify. We're going to end up with C2 is equal to, the calculation is going to end up being 12 sine 44.283 divided by the sine of 20.5. And then as we simplify that, when we type that into our calculator, we're going to get a value of 23.924 meters. And so that's going to give us all of our values. So we've got our C2 to go along with our B2, our angle C2 right there. So in green we have the second triangle highlighted, and then if we look at our C1, that would be our angle C1 and our side C1. So you'll notice that what we come up with are the full solution, angle B, angle C, and side C for one of the triangles, and angle B, angle C, and side C for the second triangle that's possible. Okay, so that two-solution case is definitely the more complex one, is the more pain in the backside one. So for The other scenarios that we're going to look at, the single solution case, where there is only one triangle, it's going to be very similar to the law of sines questions that we were dealing with when we had two angles and a side. And then for the last example, we'll look at a no solution case. So for the second example, we're going to look at two sides and an angle. So let's say, this is example 2. In this case, we're going to be given angle A is equal to 42 degrees. Side B is going to be equal to 12 inches. And side A is going to be equal to 22 inches. So here's the scenario that we have for the second example. So again, the only thing that we can really do first is, since we have A, B, and A, is we can set up our law of sines to find angle B. So 22 over sine 42 is going to be equal to 12 over the sine of angle B. In order to solve that, we're going to get 22 sine B is equal to 12 sine 42 degrees, and then of course we're going to divide by 22, so the sine of angle B is equal to 12 sine 42 degrees divided by 22. And then just like we did last time, we are going to arc sine that fraction right there. We're going to arc sine, because doing an arc sine on a sine is going to be the inverse, and therefore we're going to simplify it out. So angle B is going to equal the arc sine of that. So if we type that into our calculators, we are going to get a value of approximately 21.406 degrees. Okay, so that's our B1. Just like we did last time, it is an ambiguous case because we do have the scenario of two sides and the opposite angle. So it is that ambiguous case. But there is a difference in this one, and that is that when we try to find B2, then we're going to get our 180 minus 21.406, and that's going to end up equaling 158.594 degrees. And the problem with that, and the reason that there's not a second triangle right here, is because if I take this value that I just found and I add it to the 42 degrees that I have right there, I'm going to exceed 180 degrees. Since that's more than 180 degrees, this cannot make a triangle. So that part's out. So, good news, we don't have a second triangle to find. So that means we just need to find two other things, and that is going to be side C and angle C. Angle C is going to be the one next. We're going to do that by doing 180 minus the two angles that we already know, and that is 42 plus the 21.406, and then when we actually perform that, let's see, 180 minus 42, and then minus another 21.406. That's going to give us a third angle of, so this angle C is equal to 116.594 degrees. And then the last thing we just need to find is going to be side C, which we're going to use the law of sines for again. So we are going to do, I'll just do the 22 over sine 42, just like we did last time, equals little c, that's what we're trying to find, over the sine of 116.594. When we cross multiply and then divide, we're going to end up with 22 sine 116.594 over the sine of 42 degrees. And if we type that into our calculator, divided by sine 42, we would get our third side to be 29.3999, so let's just call it 4. And remember, we were dealing in inches in this particular problem. So, in this case, we actually only ended up with 3 values total. We had angle B that we found first, angle C that we found second, and side C that we found last, remembering that we did try to find B2, but it didn't work because this value and this value were already over 180 degrees, so a triangle is impossible to make with those values. And that brings us to our third scenario, which is going to be your favorite problems out of the ambiguous case, and that's going to be the no solution case. So we're going to start the process the same way. So, for example 3, this time side A is going to be equal to a length of 15. No units on this one. Side B is going to equal a length of 25, and angle A is going to be 85 degrees. So we're going to start off the same way. We're going to set up the same thing. Again, the only thing that we can actually find is angle B. And now that I put my dogs outside, I can continue. So just like we've done, we're going to set it up by doing our 15 over the sine of 85 is going to equal 25 over the sine of B. Remember, angle B is the one that we're looking for right here. And so when we do our cross multiplication and solving, so 25 sine 85 equals 15 sine B. And then when we divide by 15, we're going to get 25 sine 85 over 15 is going to equal sine B, and again we're going to arc sine both sides. So that's going to leave us with B equals, and then when we type all of this into our calculator, we should get an error. And that's because this value right here ends up being approximately 1.66, and if you remember from our studies of trigonometry, that's not possible. Sine can never be greater than 1, so what we get is an error message from our calculator, and so what that tells us is that there is no solution. And that is the end of the work for the whole problem. If there's no solution, then there is no solution. There are no other sides to find because there is not actually a triangle that exists. So, there are the 3 scenarios for the ambiguous case, and the problems you'll be working on today will be some ambiguous case, and some will be not ambiguous, and it's really going to be up to you to recognize when I have two sides and an angle versus when we have two angles and a side to be working with.